Zoom it in. Okay, so a limit, guys, is an operation that enables the determination of a difficult to calculate value. So as we saw before, it was the summation all the way up to infinity, Levi. We're going to start off a little bit simpler. Consider we have the limit of this statement x plus, what's your favorite number? Don't even think about it, Dusty. In all the wide world, what's your favorite number?
13.
Okay, we want to apply this limit operation to this expression x plus 13. And the limit we're observing is that as x approaches the value of 10. Now what we need to think about that here is whenever we see limit, the value underneath, the variable x, is turning into the number that it's given. So x is going to turn into 10. Now, if we just want to be very smooth-brained and not really think very carefully about this at all, we'd say sub 10 into x, add the 13, we get 23. But that's a simplistic way of thinking about it. What we need to think of is we ask ourselves, what is happening to the expression as x is becoming the value of 10? And basically that expression turns into 23. What does it turn into, Foreman?
23.
Basically 23. Do you understand the difference? So the idea is that x isn't 10. Don't worry, I'm just picking on you, Foreman. X is not 10. It's becoming 10. So whenever we evaluate this limit of x becoming 10, or as x approaches 10, this statement basically becomes 23. Does this make sense, guys? It's not 23, it's basically 23. Okay, so this is our limit, and we write it as x approaches. It's basically 23. It's not 23, it's basically 23. How cool is that?
Yeah.
Not 23.
Basically 23.
Pretty much 23.
Pretty much.
It's as fairly close to 23 as it's ever going to be.
Essentially 23.
It's essentially 23, I like that. Okay, what we want to do is evaluate. We have limit of, give me your favorite expression, don't even think about it, Jackson. Favorite expression in the whole wide world, what variable do you like the most? Don't even think about it. Okay, you need to think a little bit. Which one?
Why?
Why? Why did you choose that? Because you didn't even think about it, came to your mind. What's your favorite number?
14.
As y approaches 2, what will this expression essentially become? As y approaches 2, what will I do to show this, Harrison? As y approaches 2, what operation will I do? I'll substitute the 2 in for the y. Am I actually doing substitution though?
Not necessary.
No. I'm observing the limit of y approaching 2. Because y isn't 2, y is becoming 2. So,
Basically,
yeah, it's basically 2. Am I right?
Basically negative 10.
So as y is approaching 2, the statement y squared take 14 is essentially minus 10. How cool is that?
Kind of cool, actually.
This right here is the premise of calculus. It's becoming. It's not is, it's what it's becoming. All right, let's do something. Is this too simple? I feel like this is too simple. Okay, B. Let's change it to x squared plus 3x. We'll put a 2x upstairs. How will we do this one?
I think it's basically 0.
Is it?
Well,
Basically substituted here.
I want you to try and see what the expression becomes as x approaches 0 without doing any work.
Zero.
It's basically 0.
Basically, essentially 0.
Okay.
Just basically.
What do we do, Little Miss Forest? What should we do here?
What is your LDX?
Social maps.
Okay. Upstairs, 2 times 0 is 0. 0 squared is 0, plus 3 times 0 is 0. What is nothing divided by nothing?
Undefined.
Undefined.
Undefined. Basically undefined.
That's what we're trying to avoid.
Ah.
Ugh.
Just basically change.
Are we happy with this?
No.
No, we don't like undefined things in math. What should we do to avoid this problem?
Change it.
Starts with F. Factorize, I'd also accept fun. What we're going to do is, we have to modify our expression before we can operate on it. 2 x's, and then factorize. What can we factorize out of this? X.
Bracket. X times x plus 3.
Okay. Eliminate the x's. Okay, let's see what happens as x approaches 0 now. Evaluate the limit. So whenever we see x, it's basically 0. So as x approaches 0 for this expression above, what's it essentially turn into? 2/3 or?
Basically 2/3.
Basically 2/3. How good is that?
Basically not.
As x approaches 0, the expression is essentially 2/3 in value. Cool? Okay. How about
It's about to get hard.
the limit of this guy. what is it effectively going to become?
Four over 0.
6.
Negative 2 times
Huh?
4. It's 0 here.
Yeah, it's just 4 over 0.
Yeah.
Basically. 4.
What do we need to do before we can do anything here?
Factorize it.
Factorize it. Why?
Because 0 would just be undefined again.
Yeah, if we try and do anything to this expression here, we're going to get an undefined value because minus 2 squared, take 4, is going to be 0. So, how do we factorize this? What operation are we dealing with? Or what situation? Downstairs, what situation's happening here?
Difference of 2 squares.
Dots. We should be able to factorize that as a one-liner. Y plus 2, y take 2. Y plus 2 upstairs, cancel. So,
Negative 2. And 4.
observe the limit when y approaches minus 2.
Oh, because there's no y, you can't substitute, so just make 1
It's pretty much negative 1/4. Is that cool?
Yeah.
Okay, there's 2 more levels of complexity. Do you want to know them now or do you want to know them after?
Chuck it right now.
No.
I like the spirit. We'll do the easier one first. Favorite letter, don't even think about it. Akifa.
A.
A. Who do I always pick?
No, Levi said you did
Did I pick us?
Okay.
No, no, no.
No, Levi, he picked somebody
No,
else.
you just
So
have
he just
to
calls
find.
that.
As the expression's 1 over A. Looks like a 9, doesn't it? 1 over A. And we're observing the limit of when A approaches infinity. Any ideas? What happens when the denominator of a fraction gets insanely large? What's 1 over 1?
1.
Okay, let's double the denominator. 1 over 2,
Half.
half. Let's double the denominator. 1 over 4.
Quarter.
Okay, 1 over
Say
32.
32.
What's happening as the denominator gets larger? The value becomes...
Smaller.
So when the denominator is insanely large, what will the value be?
Very small.
Insanely small. So small, would you even notice it?
Yeah, I don't
Basically 0.
It's basically 0, right?
Oh.
All of a sudden, you've got this way of dealing with values of infinity or undefined. It's so big, it's undefined. Okay, and here's the final level of complexity. That was D. E. And I did manage to stump my stage 2s doing this one the end of last year. They hadn't seen this before. Favorite letter, don't even think about it. Leishman. W.
Oh my god.
Okay.
To what?
No, it equals basically nothing.
Wait,
Oh.
shouldn't it be W, not X?
There's no W's in
That is a W.
I can tell, I don't know what they're talking about. So.
It was basically a W. what should we do here? We try and evaluate the limit. No luck. Undefined. What can we do? Good, but is it irrational? Maybe. Maybe not.
Huh?
I'll give you a hint. We don't do anything to the denominator here.
Up the numerator.
What are we going to do to the numerator? Did you guys ever learn completing the square in the form of giveth and taketh? You giveth an amount and then you taketh.
Yeah, maybe not.
Oh,
Yeah.
I don't know.
What do you need?
yeah, no, it
You
is.
take 3.
What do you need to giveth to turn this 3 into a 4 and have no fraction at all?
What?
Give it one.
Giveth 1.
Chuck us a 1.
Chuck us a 1, lad.
1930.
Okay, we want W plus 4, and if we giveth 4, how much will we taketh?
One.
No, we'll take a 4. And then we'll have our 3 at the end. You give 4, you take 4.
Oh, yeah.
You split 0. W plus 4, W plus 4, plus W plus 4. What's minus 4 plus 3?
Maybe 1.
Yeah, I gave you a wrong question.
Oh, wow. Still undefined.
It is.
Yeah.
Now let's change it to
Zero,
a.
zero, yeah.
Let's just change it to infinity. Okay.
Write it down, man.
I gave you a bogus question. I got too excited. No, we'll change the limit to infinity. That way it will work. You wouldn't have been able to do the top line anyway if it was infinity. The point I'm trying to make here is you can do this operation to the fraction where you giveth and you taketh to remove that guy. Because what does this turn into? Nothing.
Approaches 0.
W plus 4 over
That's
W
one.
plus 4.
One.
What does it turn into?
1.
1 or basically 1?
Basically 1.
No, just 1.
Oh.
Because we haven't done the limit yet.
Oh, okay. Yeah.
Top of Harry.
Okay, now we need to think about this. Let's evaluate the limit. We get 1 minus. What is going to happen to this fraction as W approaches infinity or gets insanely large?
Insanely small.
It gets insanely small. How small?
Basically
Basically
0.
zero.
Oh, yeah.
Are we cool with this, guys?
Yeah.
Okay, so this is a really novel technique. It was discovered back in the 1800s, firstly by Isaac Newton, the father of calculus, and co-discovered by Leibniz. I can't remember his first name, but they had a massive fight, and continental Europe and England stopped talking to each other over this incident. But the idea is we're looking at how things are changing, not what things are. If you think of limits as simply it's turning into this or I sub this in, you're thinking about it all wrong and you will not understand this topic at all. You need to think about it as what is it becoming? It's basically becoming 1. The D was basically 0. C was basically negative a quarter. Seem okay?
Yeah.
All right, so that's why when we look at this model over here, when we reduce the value of h, what are we basically looking at it as? As h is becoming
Smaller.
nothing, where we use our limits here. Cool? All right, what you guys are working on to build your understanding of the topic is over on our OneNote. It's learning intention 2. It's called limits. we start ourselves off in fairly routine stuff. You don't have to do much here, you just evaluate. As you build your way down to 2, 3, and 4, you're going to have to modify the expressions ever so slightly to get a defined limit at the end, sorry, a defined answer at the end. For question 5, do you guys remember sigma notation from methods A?
Yeah, I do, I think.
Question 5's not really part of the topic we're doing now. However, I do think it's a valuable exercise to do because it's bridging two pieces or two topics in mathematics together, which demonstrates a firm understanding of this concept today. Are we cool? Alright, the work solutions are done, I just haven't uploaded them yet. I will do that any moment now.